In this lesson, we're going to talk about points, lines, and planes, the undefined terms of geometry, really the foundation for everything you're going to learn this year. So we're going to start with the point. A point just shows location. It doesn't have any dimension. It's not a big point or a small point. It's just demonstrating the location. We name it by using just a capital letter. So for example, right there is point B. So its name, I would just say B. So we don't need to write a word in front of it or anything. It's going to look like that. We name it B. A line. A line is a set of infinitely many points, continues indefinitely in all directions. So a line might look like this one right here, line AB. So I'll draw that. The way we name a line is by using any 2 points that are on the line and putting this symbol on top of it. The line symbol indicating that it goes infinitely in both directions. We can switch the letters. We can pick any 2 points that are on that line. If the point C is in there, we could even call it line CB. Another way we can name a line, occasionally there will be a lowercase cursive letter next to our line. So I could also call that line L. So if we're naming it by the letters, we pick any 2 points and put the symbol on top, or we could use that cursive letter. The next terms we come across are collinear and non-collinear. Collinear means that they lie on the same line. So for example, in this picture right here, we could say that A, B, and C are collinear because they lie on the same line. So non-collinear means they don't lie on the same line. So if we look at this picture above on the far right, I could say A, D, and B are non-collinear because they do not lie on the same line. They kind of make a triangle. So non-collinear points look like they would make a triangle because they don't lie on the same line. Now next up we have a couple of postulates or theorems to look at. This one says, through any 2 points there exists a unique line. Any 2 points, there is a line. So back up here on the far right, is there a line named AD? Well, it's not drawn there, but could I draw a line from A to D? Yes. So that exists. If I give you any 2 points, you're always going to say yes, that line exists between those 2 points. 2 lines intersect at a point. So if I have 2 lines, I'll call them line L and line M, and I asked you, where does line L intersect line M? You would pick this point right there. I'll just name it P. 2 lines intersect at a point. Next up we have line segment. A line segment is a part of a line, but it has endpoints. It does not continue indefinitely in both directions. So a line segment might look something like this with the endpoints. We name it with the 2 letters, the 2 endpoints, and we put a segment bar on top of it. I can also reverse those letters and say segment BA, and I'm talking about the exact same segment. So you name the endpoints and put the bar on top. That represents a line segment. Next up we have a plane. A plane is a flat surface. It continues indefinitely in all directions. So indefinitely in all directions. So you think of something like your desktop. is an example of a plane. I know your desktop doesn't continue indefinitely, but it's a sample of part of a plane. The ceiling, the floor, the walls, those could all represent planes. Normally in geometry, when we're looking at our papers though, a plane would be represented by a parallelogram, like the one in this picture right here. We have two planes. There's a plane, we're going to call it plane P, noted by this cursive or script capital letter in the corner. And this one down here is plane R, noted by the cursive script letter. So I'm going to call this plane P. So we could name it plane P by using that cursive letter in the corner. It doesn't matter which corner, but there's usually a cursive or script letter in one of the corners that is not labeled as a point. So if you look up here, see, notice P doesn't have a point associated with it. We can also name our plane with 3 non-collinear points. 3 non-collinear points. So if we look up at our plane, let's see if I can draw this for you. There was A, D, B, and there's a C and an E. If I'm just looking at plane P, the one that's going horizontally. So if I want to name plane P something other than plane P, I would pick 3 of these points, but they have to be non-collinear. And I'll tell you why in a little bit. So I could name this plane ACD. ACD. 3 points that are on the plane but are not on the same line. I could name it plane EBD, or any arrangement of those letters. So you could name it with just the letter in the corner, or you could name it with 3 non-collinear points. The next definition we have is coplanar and non-coplanar. So just like collinear and non-collinear, coplanar means they lie on the same line. I'm sorry, on the same plane. And non-coplanar means they do not lie on the same plane. So let's see what that looks like in our picture. So we're looking at this third picture at the top of the page. So if I want coplanar, I could look here and I'd pick 3 points on, actually you'd have to pick 4. Coplanar, I could say A, B, C, and D. A, B, C, and D. Those all lie on plane P. They are coplanar. Non-coplanar, I might name something like A, C, D. Notice, okay, A, C, and D. Those are all on plane P. And then the fourth one, I'm going to say F. F. Nowhere near being on plane P. So those 4 points are non-coplanar. When we start talking about coplanar and non-coplanar, it has to do with 4 points. Collinear, we were looking at, did the third point make a straight line? This one we're looking at the 4th point. So A, D, and C, same plane. B, still on the same plane, coplanar. But if I said A, D, C, and F, they are non-coplanar. A couple of rules about planes. Through any 3 points, there exists a plane. So without giving you a picture, if I said, do X, Y, and Z make a plane? You would say yes, because they're 3 points. But if they're 3 non-collinear points, there exists one unique plane. And I'll show you that in just a second. Let's look at this last one. 2 planes intersect at a line. So we're going to go back to our intersecting planes picture. Take a look at points A, D, and B. Notice that they line up in a straight line. They are in plane P, but they're also in plane R. So we said 3 points, through any 3 points exist a plane, but if they're non-collinear points like A, D, and E, they make a specific plane. If they're on the same line, they could represent many different planes. If they're non-collinear, they only represent one plane. Here's another example. What is the intersection of plane P and plane R? Where do they meet? Well, they meet right here. I could call that line AB. If you wanted to call it line BD, you could, because line BD represents the exact same line as line AB, because it continues on forever. So the intersection of 2 planes is always a line. And we can examine that also in the second picture, our rectangular prism. If I was asking you, what is the intersection of plane A, B, D and plane G, F, D in this rectangular prism? It looks like a box. There's a couple of ways you could identify them. Plane ABD represents the top of the box. Plane GFD represents the front of the box. So that you're asking yourself, where does the top of the box meet the front of the box? And you would probably say at BD. Now we said the intersection of 2 planes is a line, so technically we should say line BD, but because you're looking at a rectangular prism, segment BD would be acceptable. Now if that didn't jump out at you, let me give you another way to look at it. Take a look at your plane on the top, ABD. I'm just going to put the 4th letter in with it, A, B, D, and C, just to look at. The front, G, F, D, if I put B, that would be the 4th point. So if you do something like that, then you look at your points and you ask, what do these 2 have in common? I see a BD and I see a BD. That must be the intersection, what they have in common. So if you're having a hard time seeing it, that's a good way to look at it. All right, rays. Ray is, I don't want to say half of a line because a line is infinite, but it's part of a line. It has an end point and it goes on forever in one direction. End point, indefinitely in one direction. That is a ray. So a ray could look like this. The way we name our ray is by using the end point first. Name another point that it goes through. No matter which direction your ray points, that is the symbol that goes on top of it. Ray CD. Start with the end point always. Always have to start with the end point. This term called opposite rays. Opposite rays have the same end point and they go in opposite directions, forming a line. So that might look something like this. So the opposite rays, I could say ray CA and ray CB. They have the same endpoint, C, and then this one goes this way forever. And then this one starts at C, goes through B, and goes forever. Those are opposite rays. Together, they form a straight line. Last up, we have an angle. Okay, it's not last. There's a few more. But an angle is just the intersection of 2 rays at their endpoint. So an example of that we could take from the picture on the far right. We could say this angle right here. Angle, I could call this angle C, just naming it by its vertex. I could name it angle DCA I could name it angle ACD. So you always want to make sure the vertex is that letter in the center, ACD, that you can trace it, or DCA. And I could just name it angle C, because there's no confusing it with any other angle C. Now, if we think about our picture at the top, it's got this other side. So if I look at this whole picture, I can't just say angle C, because then do I mean the one on the left or the one on the right? So if that's the case, you would have to use the 3 letters. If there is no other angle to confuse it with, you can just use the vertex. Another way we name our angles, sometimes if there's a lot of angles and a lot of letters, we'll just number the angles. I could call this angle DCA, I could just call it angle 1. And we would know, oh, that's the angle C you're talking about. 3 last definitions. The first 2 I think you know. Parallel are lines that never intersect. Intersect. So parallel lines, like the lines on your paper, might look like this. And the way we're going to know they're parallel, don't go by, well, they look like it, because you never know who drew it and it might not be what it looks like. But what we're going to know is if there's this little symbol there, this little arrow on it, that's going to be our symbol that says, hey, those are parallel. L is parallel to M. There's our symbol for parallel. It's easy to remember because it's like the double L's in the word parallel. L is parallel to M. The only way we know that lines are parallel is if someone told us or if it has the symbols marked on it for parallel lines. Perpendicular lines. Perpendicular lines intersect at a right angle. We're very specific about this definition. So don't say they intersect at a 90-degree angle, but because that requires an additional definition. When we say perpendicular, they intersect at a right angle. And there's 2 ways we can know that. I'll say this is L and this is T. 2 ways they can tell me that the lines are perpendicular. They could put a box in the corner, which means that's a right angle. Or they could use the symbol. T is perpendicular to L. That's the symbol for perpendicular. So you don't have to write the word. If you want to use perpendicular, you can just use that symbol. The last one might be new. It's the word skew. Skew are lines that never intersect, but they're not parallel, and they're not in the same plane. Parallel lines are in the same plane. Skew lines are not in the same plane. So let's go up to our rectangular prism and let's identify some lines. So parallel lines, I could say AB, CD, EF, GH. Those would all be considered parallel lines. This is the most confusing one. AB and EF, not everyone quite gets that those are parallel. But those are all on the, these 2 could be considered coplanar because there's a plane that goes diagonally through the box. Okay, perpendicular would be, for example, AB and BG. Those would be considered perpendicular because I told you it was a rectangular prism. Skew. Skew could be AB and DF. Look at those 2. They are not parallel, but they're never going to intersect. This one's on the left going front to back. This one's on the right going up and down. Those are skew. Another example, we could say EH across the back and DF for that matter. EH is across the back, DF is in the front. They're never going to intersect because they're going opposite directions. So those are examples of your definitions. A lot of definitions today, And these are going to carry us through the entire year of geometry.